When recording guitar, there may be times when you want to put some distance between you and the guitar amp. Usually this is because there's other microphones in the area and you don't want them picking up a bunch of bleed from the guitar amp. So the solution is simple, get a longer guitar cable, right? No, I'm afraid not. No? Nope. And here's why. Here's a guitar with a 10-foot cable. And here's the same guitar with a 200-foot cable. As you can hear, when we use a long guitar cable, it sounds like someone turned the tone control all the way down, killing all the high frequencies, or treble. Well, as a matter of fact, that's exactly what happened, just not with a knob. In this case, the cable was the equalizer that killed our high end. But why? A simple tone control equalizer is actually a very simple electronic circuit. It consists of the tone control knob, which is a variable resistor, and a capacitor. As you change the resistance value with the tone control knob, it changes the electronic relationship with the capacitor, and the result is a modification of the guitar's tone. Now, the same kind of interaction can happen between the guitar and the cable. The two of them together make a kind of equalizer. In this case, the guitar is the resistor, and the cable is the capacitor. Wait, the guitar is a resistor? Okay, let's back up and talk about impedance. Impedance is a kind of resistance, a property of electronic components that will slow down electronic current flow. Actually, impedance is the vector sum total of resistance and reactance, but I'm going to spare you the math and keep it simple for now. The output of any audio device is going to have a certain amount of inherent impedance, and likewise, the input of any audio device will also show an impedance value. This is abbreviated with the letter Z. So if you've ever heard someone talk about a low Z microphone or a high Z guitar input, they're talking about impedance. Now here's the rule about output Z and input Z. The input Z of any audio device should be at least 10 times higher than the output Z of the device you're plugging into it. So let's say, for example, we're plugging a microphone into a preamplifier. The output impedance of this microphone is 150 ohms. The input impedance of this preamp is 10,000 ohms, so we're in good shape. And usually you don't even have to think about this. But there are some devices that have high output Z, like guitars. The typical output Z of a guitar with passive pickups can be 10,000 ohms or higher. That means that the device you plug into needs to have an input Z of 100,000 ohms. So plugging a guitar right into the line level input of this mixer is going to cause us some problems, like line loss and a compromised frequency response. This is what Super Z inputs are for. These are super high impedance inputs that allow us to plug a guitar directly in without any line loss. Actually, if you're going to record the direct signal from the guitar, it's best to use a direct box, but we're getting off track. Okay, back to our guitar and cable equalizer thing. Remember that the tone control is made up of a resistor and a capacitor. The guitar, as we just learned, has a certain amount of inherent resistance, its impedance. The cable, because it's made up of a bunch of electronic conductors separated by jacketed insulators, which is exactly what a capacitor is, they have a certain amount of inherent capacitance. So as the cable gets longer, we introduce more capacitance to the system, and our high frequency response goes down. In other words, adding more cable length is like turning down the tone knob and making everything sound muffled. So this happens with all cables? Yes, all cables have this issue. Then why doesn't this happen with microphones? Ah, good question. Well, remember that microphones have a very low output impedance. This allows us to have a much longer cable run before its internal capacitance causes us to have any audible high frequency loss. So, cut to the chase, how long is too long? Well, if we knew the capacitance of the cable that you're using and the output Z of your guitar, we could use this formula to determine the exact length that we could have before you have any audible loss below 20 kilohertz. No? Okay, forget the formula. The generally accepted rule of thumb is to have a guitar cable no longer than 10 feet. As far as microphones go, depending on the per-foot capacitance of the cable, it could be as much as 1,000 feet before you hear any high frequency loss. However, it's still a good idea to keep your cable runs as short as possible. This is to reduce the risk of electromagnetic and electrostatic interference. So back to our original problem, how do we get this amp out of here? Okay, the first solution is easy, but it only works if you have a separate amp head and cabinet. Put the amp head in the room with you and connect it to the speaker cabinet in a separate room by a long speaker cable. The amplified signal from the amp to the cabinet can be run for fairly long distances without any loss. From there, you just mic up the cabinet and send that signal to your headphones. But if you have a combo amp like this one, it becomes a little more challenging. There are a number of tricks out there for this, but one in particular that I've always used is the double DI technique. To do this, you will need two passive DI boxes and a female-to-female XLR turnaround. First, set up your amp in a separate room and mic it up. Plug in and get your sound exactly the way you want it. Next, set yourself up in the room in which you'll be playing. Plug your guitar or the output of your pedal board into the first DI box. This steps the signal down and converts our output to low impedance. Now run the mic cable into the room where you have your amp. Use the turnaround to plug the mic cable into the second DI. This steps the signal back up to high impedance. Then plug the 1/4" connection from the DI into the amp. Now, if you're looking for advice on getting a good guitar tone, I admit that it's not my specialty, as evidenced by the guitar and amp I was using, so I put a few links in the description below to some YouTube channels that might help you out. Okay, don't forget to like and subscribe. See you next time.